Server system security team. This is Omar Lopez Castellanos. I'm back with another video, and we're going to be discussing databases today or tonight. First, we're going to be talking about what exactly is a database. Then, the database that we're going to be exploring for the Linux server is PostgreSQL. We're going to learn how to configure it. I'm going to give my recommendations for how to harden the security around it, and then conclude. First, we do have to learn the answer to the question: what exactly is a database? We hear that word often, but do we really know what it is? Some might say a collection of data. Well, you'd be more or less right. But let's go for the formal definition. So it is a very simple definition, but also scary. It's basically an organized collection of logically related data. But we gotta wonder, what is data? It's structured information meant to define a quality. Now, in database systems class, we could probably define information as structured data. The definitions can go either way. There are many different types of databases, like the hierarchy. You would imagine a hierarchy to work like a tree structure, as if you would know who's the top boss and up to who are the foot soldiers. Then there's the network, where the linked lists, everything's connected via nodes, but that creates different relationships instead of everything being related to one singular source. Then there's relational. It's the most commonly known database, and it's in the format traditionally of a two-dimensional table. And one might think, wouldn't that just be a spreadsheet? It's not. And we're going to get into that later. Finally, there's the object-oriented. For anyone who's taken the basic computer programming classes, you would be familiar with object-oriented programming. Basically, where the entities or the nodes, as you would imagine, in database structure design, they're treated as classes with objects as their manifestations. And with that, they contain attributes, which can be displayed as like the columns. Imagine a table with rows and columns. Each row is its own entity, whereas the columns would count as attributes. They are the properties that describe and define an entity. Now, all the database simply is information that's structured and set up and modified to allow easy access, management, and updating. And with relational databases, you can learn how different entities relate to each other via their qualities, otherwise known as attributes. Now, for relational databases, the standard is SQL, or people sometimes also pronounce it as SQL. So instead of compiling, as you would imagine, into machine code from object-oriented programming, you're going to make requests for data, also known as queries. That is where you get to display and showcase the information how you like in a table format using SQL. Now, what makes a database different from a spreadsheet? It's usually the properties of data storage, manipulation, and access. Spreadsheets are usually meant for a single group of people or just one user. So they're meant for display for just one group to understand one concept and then be done. Whereas databases are meant to be more lasting. They're meant to hold massive amounts of information for numerous users. And it's consistently updated, consistently modified, consistently streamlined in order to be relevant, to continue for the data to continue to be processed and harvested from the databases. PostgreSQL, it's a database management system. First, we have to know what that is. It's basically a system meant to manage a database. You create, edit, and maintain databases in there, and it counts as the interface between the end users, us, and the databases we wish to play around with. I mean, how else will users retrieve and update those databases? Now, PostgreSQL is an enterprise class, meaning it deals with a heavy amount of information. And it's open source, meaning that this can be edited and modified and customized for our liking. And it's a relational database that supports both SQL and JSON, which is a non-relational query structure, for for numerous users, and it's been responsible for the development of so many applications and companies such as Cisco. Now, you might imagine, what kinds of applications? Web, mobile, geospatial, and analytics. There's just so many more applications that wouldn't have been possible without the implementation of PostgreSQL. What features do exist? Table inheritance, for example. This means that you can create tables and have them inherit properties and attributes from different entities as long as you establish a connection. That's when you're going to have to define the types of entities you're dealing with. So that's where user-defined types, that property is very important. And then there's foreign key referential integrity. Now, when we're creating databases, we usually have every entity be identified by a primary key, a primary source of identification. For example, one might use an ID number or a hash as the primary identification. Foreign keys act as secondary properties for those primary keys. That means we can allow different tables and databases to be related to each other via the sharing of these foreign keys. And imagine it as a table. Foreign keys are columns that can be used to link data between tables and thus discover the relationship between different entities and different databases. So how are we going to configure PostgreSQL on Ubuntu? Simple. I've already placed the Linux command. Just got to make sure everything's updated first. Forgot to add that, but this is essential. At this point, it's a no-brainer for some people. This Linux command will ensure that the latest PostgreSQL version is added. Then you have to check the status because you got to double confirm that the daemon is active, or else we're not going to be able to make any more progress. Now, how are we going to harden these ports? Installing it, you got to configure the port to hear that traffic. The Linux command for that is posted above. But how do we harden it so that way we can ensure that it just doesn't accept any kind of traffic? What we can do is modify this command to be even more strict in accepting connections. That way it can accept connections only from certain IP addresses or subnets. For example, imagine that we wish to access only a local subnet known as 192.168.1.1.0. So the example command below allows us to access connections to the port of PostgreSQL, which is port 5432 by default, but ensures that only from this particular local IP address is accepted. It's very useful when you're trying to only allow certain users access to your database. Authentication. Now, we're all familiar with authentication, two-way and everything, but when we're using the Linux server, we got to make sure there's plenty of authentication above plain text, so I would recommend MD5 authentication. It uses a secret shared key to verify a packet that contains an encoded MD5 checksum, which counts as the primary identifier of the authentication. It provides better security. And how do you do it? You create this file that I posted below, make sure to edit it, and ensure that line, local all Postgres MD5, is written. And if you want more specific instructions, I've included the link in my references. Then you got to restart the service to initialize that the new configuration is solid, just like how you would have to restart the configuration of an IP tables after you've modified it. Got to make sure that there is secure encryption enabled. Use the transport layer security. We've already done this in many videos, but I'm here demonstrating another way you can do that. Create another text file, and in the red text, you're going to have to know your own domain and replace it there. Then in that line, you got to make sure that these lines are configured and written exactly how I presented them. What this does is that it allows the lines to specify the location of this acquired TLS certificate and private key that you need to establish. Allow the order of ciphers to be preferred over clients, which enables us to prevent any unwanted attackers from potentially entering the system. And finally, ensure that any insecure or obsolete versions of SSL or TLS are disabled. So you would want the default, the bare minimum, to be version 1.2 of TLS. Now, these are the works cited. For more specific instructions, please reference these links, and I'm happy to have provided a little bit more knowledge. Thank you very much. Bye.